can also give 4 or 5, which is your choice. Okay. Now what I'm doing is that I'm creating a matrix that contains the space values and the space values and the function values. So the entries, so the prime symbol stands for transpose operator. Stands for transpose operator. Okay. So when we call n prime, what it does is that it will write the column vector un1, the row vector un1 up un2 up to un9 as a column vector. What does that mean? It will write something like un1, then the next entry will be un2, then up to, you go up to un9. Okay, like this. Now when you call a is equal to x space prime uhn prime, so it will put the first column as x space prime and the second column as uhn prime. So what will that look like? So a will have the structure something like x1 un1, then x2 un2 to xi un. So these are the values. So now look at this. Now it's very logical. What is A contains? A is the spatial variables and the corresponding time, the space data at time tn. Okay, so this is u of, this is approximately u of tn x1. Similarly, this is approximately u of tn xi, and we are plotting this guy, the x values versus the y values. That's what we are doing. So what we are doing is that we are creating we are opening a function, a file, namely grid name. Okay, and giving it write permission. So MATLAB can write data into it, and a pseudonym is given, that is called fname. Now firstly what we are writing is the, I'm sorry, I haven't written this command, the 57th line in the code I explained before the lunch. Okay, so this is actually the space and variable x and y variable name. So what we are doing is that we are printing to the file named fname, which is grid name, which is in our case it will be tridata.00n csv. That file we are allocating space for 5 string variables, again space for 5 string variables. The first space for 5 string variables I will write xval, comma, that is the first, it tells the computer that the first variable is the x data and the second variable is the y data, which is u value. You can give any name, x value, y value, something like that. So that you are able to distinguish between these things. Okay, now there is then I am just printing a of y1, that is xi x1, so it will be xi and corresponding u value at time tn, that is u of tn of x1, that is uni. Okay, and finally I run this again, it will come, I close that file, then again it will go back to the beginning of for loop, time loop. It will open another file at time 2, again write the space value to that and close this. Okay, so in this way it will create all output data. So maybe I will go to the output file. Okay, I haven't shared the entire screen. Go to GC. Wait a minute. Yeah. I'll share my screen. Okay. So I can hide the controls. I can open. Okay. What I was doing is that I will go to the output folder and I will open code pjc transport and I will delete the output folder. So I will create another output folder, and where we can save our data. So the output folder is in the same folder where the code transport one is present. Look at that, transport one is present here. So to create the folder there itself. Now let's run the code. We will increase a little bit higher, 200. Sorry, delta by 2 maybe. Your choice. Okay, let's run the code. Yeah. It's moving slowly. There's a slight lag, yes. I think it stopped. Let's check the command window. Stop. Now let's open the output file. Yeah, see, it has generated all this data. Now I will tell you how to import this to ParaView. It's very easy. Some technical issues, my ParaView is crashing all the time, so I may not be able to save the animation, but I will show you how to do that. Okay. So as I said, ParaView is a beta version software all the time, so it's a little bit difficult, it suddenly it crashes or something. So this is one of the issue with freewares. It's a very robust tool, but still sometimes it behaves very erratically. Yeah. So now you see all files are selected in the output folder. Just click on that and drag that into the ParaView console. Select everything and then press drag. So all 27 files will be simultaneously imported into the console. Okay, so you can see the data here, but it is floating nothing. So this is the problem with ParaView. You will be worried, you will import some data but no plot is being shown. So then you will wonder, okay, why this is happening. The issue here is you have to select what kind of data you are importing. So what you do is that go to filters. There is something called alphabetical. So if you press on alphabetical, you can see a whole lot of options. Okay, different data types. So in that, press plot data. Okay, so it will show a figure. Now we can delete this spreadsheet and the render view. Again, there is a problem. We have two charts, the red line and the black line. Okay, the red line is the x value plot. Okay, now you go to the properties window where we have to take the leverage of it. So if you look at here, there is something called series parameters. Okay, the series parameters view, both u value and x value are selected. That's why it is plotting both the axes. So you do one thing, uncheck x value. So it will stop plotting it. Okay, now we have only the u value, but the problem is it is plotting against the index. Okay, how many indices are on x space, that is plotting. It's not plotting against the x values. How do we change that? Again, look at here, x-axis parameters. There is a title called x-axis parameters. There is a small tick here, use index for x-axis. It is checked. That's why it is using index values for x-axis. Uncheck that one. Okay. So now it is, and go to x array name. So this is the array that is going to use in the x-axis. There, select x value. Okay. Now you see the x-axis is x space, that is 0 to 2 pi, 6.5, and y value is 0. Okay. Now to see the animation, Now we can give axis title and all. Okay, I'm going to give a chart title. This is concentration versus space. We can change its font to whiteboard. If you are fancy enough, you can give some nice color. Okay. You got the idea. You can now give the axis title also. You go down. There are options to give these titles. You can give left axis title, that is concentration. Is the pace okay? Should I go fast or slow? Just give the answer in chat box.
Slow.
Have to slow down. Okay. Yeah. So maybe I will start from again. I hope you understand the importing of the data. Is that clear? From main window to ParaView. Okay. After that, maybe I will show you again once again. Okay. So everybody can catch it. So we have this one. Open the output file. We have here and ParaView here. Okay. What you have to do is that select everything here. Click on one thing. I cannot show you. You can see in the small box. I just select everything. Click on this one and drag it here. Okay. So the data will be imported. Then what you do is that select TR data. Maybe unselected. Select TR data. Go to filters. Choose alphabetical and choose float data. Okay. Then we don't need the spreadsheet anymore. Close it. The issue here is there are two ones, the red one and the black one. We don't need the red one. So go here and unselect XY on CS parameters. So the red one will disappear. Now look at here, the x-axis is indices. The problem there is in the x-axis parameter, we have checked use index value for x-axis and check that. And x-array name, select to x value. Okay. Now you can run the animation. See, it's much smoother than the MATLAB animation.
I'm not able to click on the plot data.
Have you selected it? You have to select TR data. See, if you don't select, it will not show anything. Go to filters, alphabetical. You will not be able to choose plot data. What you have to do is that you have to select try data. So it will be a small blue color will come, and then go to filters, alphabetical. Then you can click plot data. Okay, we have to do the same business again.
While saving, we don't save the time data.
Time data means what?
Like
Yes.
the time instance for which, like we have saved only x value and v value, right? Not
Yeah.
the time value
For
corresponding
fixed
to that.
time.
For each snapshot you are seeing in this animation, for example, look at here, this time. Okay, so this one that corresponds to the time value, time indices. You can
Those are
explicitly type, those are indices. You can explicitly give the time values also and annotate that. There's a way to do that in the legends or somewhere here. And you can make the legend also in the animation.
In that
But
case, then
that,
we'll have to, while writing the data, we'll have to write the time as well, right? Like X location, say U value, and also time, the T value.
T value, I mean, it's a continuous variation. So, you know, you can, yeah, what I can think of is that you can give like a box here that shows the variation of time. You cannot give every time value at the same time because, you know, it's an animation.
What if these time slices are VTK files?
Yeah, we will show that the VTK files later. Yeah. Now what we have to show is that save animation. Somehow my ParaView is crashing when I'm trying to export this one, so to bear with me. We'll try once again. It may not work. So I'll go to C, users, mesh, Dropbox, and then write transport mode. Okay, so AVI. Somehow it's getting stuck when I'm trying to export. It's maybe my computer issue. It was working yesterday, but that's the procedure. I mean, it got stuck again. Okay. Oops. Somehow it's getting stuck. I have no idea. So let me just force stop ParaView. Maybe it's because so many programs are running together. It's getting stuck. So I hope you understand what's happening. The exporting, I'm unable to show the the saving part because of some technical issue. So is this clear? Can we move to the post-on one?
Yes. Yeah.
So next one is a little more serious code. So I will show you open the Poisson equation, how we can solve Poisson equation. So we have to go to EJC code, Poisson, and solve this. Yeah. Now, so yeah. So Rekha morning explain what's algorithm, how we can solve all these kinds of how we are writing a pseudocode for solving Poisson equation. We will just recall the Poisson equation part again. I have the notes here. This is not updated, so
This is updated. Yeah. Dropbox now.
Yeah,
This
that's
one.
also.
Which one open?
Okay, so transport equation, we have Poisson equation. Yeah, so that's 1.2.1 is Poisson equation. We're just recalling everything. Del xx u plus del y u is equal to minus f, and then we have some homogeneous boundary data, which means the clamped boundary condition, and we wrote the scheme here in morning. Okay, we have 1.2.2 that says, you know, ui plus 1j plus ui minus 1j minus 4 uij plus uij plus 1 plus uij minus 1 is equal to the source value. Okay, and we introduce the linear pseudo indexing, the m value, which is 1 plus j minus 1 I. So what Vega said morning is that for each ij we will get one equation. So there are j square unknowns and j square equations. Okay, and we are converting that into a matrix system, au equal to f. So what we have to find is u from the equation au, from the matrix system au equal to f. Okay, so what we want is finally the coefficients of the matrix A and what is f. Yeah, now how are we finding the coefficients of matrix A? That we can put ij equal to 1. So what I told morning is that ij 1 1, when I and j is 1, 1 1 is going to 1, linear indexing 1, 1 2 is going to, sorry, 2 1 is going to 2, 3 1 is going to 3, up to j1 is going to capital J. Then we start from the next jth level. That means 1 2 is going to j plus 1, 2 2 is going to j plus 2, up to j2 is going to 2j. Similarly, we are going to the next level up to will reach the jth level. So this is the linear indexing. So we write the scheme for each uij, each xi yj. We will get an equation, and then we will look at that equation and we will get the coefficients of it. So we write this. Reka told morning told that how do you write this guys as a column vector. Okay, so you first stack u11, u21 up to uj1, then u12, u22 up to uj2, etc. up to the jth level. Okay, so that will be the matrix system. So we have sent these notes to everybody. Have a look if you don't understand. It's not very difficult. Yeah, so we have the coefficients here for each case. So maybe I will show the pseudocode, that will be easy. We have to first construct the source step, f step. That is, we call it as B. Okay, so we run a loop over j and I. We define m as I plus j minus 1 into j, and we call b of, say, b of m is equal to minus h square f of xi yj. Okay, maybe I will show you first this one, and then I will explain the matrix implementation second part, how this is being. So we will just look at this guy, how the source term is assembled. Okay. So please ask questions if you have. It's a good chance you can get questions here. It's a little bit confusing, even for somebody who's experienced. Can you see my MATLAB screen? Yeah. So this is j is equal to 20. I give some number, how many values I want to save, how many discrete nodes in here. And as we did in the transport equation, we divide x into j plus 2 number of poles. So from 0 up to 1, I have j plus 2 equally distributed poles. Why I give j plus 2? Because we have j square unknowns. Okay, there is 1 0 that is unknown, and j plus 2 that is also unknown. So in between there is 1 to j plus 2, that is j square, j nodes. So when you take the cross between x-axis and y-axis, you will get j square number of unknowns. And there is now there is something called sparse command. I tell you what is sparse command. Okay, so this is an optimization strategy usually used in MATLAB. Okay, not optimization, memory saving strategy used in MATLAB. So what sparse does is, sparse will not, so it recognizes u as a matrix where most of the entries are zeros. That's called a sparse matrix. Okay, so you will say only all non-zero entries in U. It will not say the zero data. It will not calculate the calculation that is coming with what any zero data. Okay, because you don't have to do it anyway. Apparently you know it's going to be zero. So understand like this. Sparse is a command that you create an array where most of the entries are 0. If you call sparse nm, it will create an n by m matrix where most of the entries are zeros. Entries are zeros. Okay. For doing finite element schemes, finite difference schemes and finite element schemes, the matrices will be usually sparse. Okay, that's why we are using sparse image. Okay, now I define my discretization factor, that is h. So this is percentage discretization factor.
Please explain sparse again.
Yeah, I will do that. Can you see here this one? There's a command in MATLAB to get memory. Can you just check that?
To get them.
How much memory is used? So let us write a command. I can initiate a matrix in two ways. Okay, A is equal to, I write zeros, comma, or 100 by 100. So what will be this? This will be 100 by 100 matrix. Okay, all entries are zeros. Okay, and I write and I will write another matrix B. So it is sparse 100. Or maybe I will.
In terms of number of elements and number of columns.
I cannot display this much number, so I will write a little bit smaller one. I will maybe call A zeros step. And B is equal to. I need to find this. I can show you guys how much memory is used to. Okay, please. Now I will just type whos of A. Yes. Yeah, it says that A is a 10 by 10 matrix and it uses 800 bytes data. Okay, why it uses 800? And I will show you another one. Now I will say B and save that as sparse 10 by 10. Okay. Now let's check. B is using only 10 bytes of data. A is using 800 bytes of data. Okay. Now, both A and B are actually the same thing. Both are zero matrices. Okay. The difference is A is forcefully storing all the zero entries. It is treating zero as any other non-zero entries. Okay. For example, if I call A is equal to rand 10 by 10 and whos A, it still has 800 bytes of data, which means that when you store something as a zero matrix or a ones matrix or a rand matrix, the MATLAB does not differentiate between zero and non-zero entries. It is allocating that much amount of memory for zero as that much required for any non-zero entries. But this is a waste of memory usage. Why? Because we know zero will get cancelled when we do in multiplication, or when we do addition it does not make a change. So these rules of algebra is known to us. Sparse matrix take leverage of that thing. Okay, so sparse will not save zero elements. If there is a zero element in a sparse matrix, and if I want to do a matrix multiplication, it will not do the multiplication by that entry. Why? Because it will be giving zero anyway. Okay, so the sparse matrix, the advantage of sparse matrix is it has a huge memory advantage. I will show you one more example. I will type A is equal to sparse. Usually, Rekha, Ruma, and my friends usually work with like 3000 by 3000 matrices. So that is A. Let's see how much memory it is used. It used 24,024 bytes. That is actually 24 kilobytes of data. Now see, if I define A as zeros of 3000, 3000. Should I? Yeah. Now let's check whos A. It used 72 megabytes of data. Right? 1, 2, 3, 72 megabytes. So sparse uses only 24 kilobytes of data, so but zeros uses 72 megabytes. That is 1000-fold increase. Okay, so that much memory advantage is with sparse command. Okay, so the difference is once runs zeros stores zeros forcefully, while sparse does not do it. It takes leverage of the algebraic rules. Is that clear? Chat box answers is clear?
Yeah.
Okay. Yeah. Now there is, I have defined, so we will create a matrix A zeros, J square. You don't have to create just zeros, you can also use sparse, okay, which is best way to do this one. So that is sparse matrix. Most of the entries are yes. So it has a memory advantage. Yeah. Now I have defined ELL equal to at ij I plus. What does this thing do? This is called inline function. Okay. Previous versions of MATLAB had an option called inline function. So inline function is basically, you don't have to define a function environment or something. You can very easily write an inline code to save data. That's called inline function. But the new versions is having something called amorphous functions. Okay. I will show you what these two guys do. Okay, if I write f is equal to inline x plus y x y, this will create a function. So if you call f12, it will give you 1 plus 2. We call f45, we create 1 plus 1. So this is a very easy, handy way of creating functions. But don't use, it's a very often way because it requires a little bit memory allocation. So always use functions if you want to create real functions. Another way of doing is called amorphous function handle. I will create another function. What you do is just type a at variables x and y, and you say x star y. So this is also another way of defining function. Just type u of 2, 3, it gives 6. Okay, so there are 3 ways of defining functions in MATLAB: as code scripts, inline functions, and amorphous functions. I always prefer as scripts. Okay. So this is to create, ELL is to create the pseudo linear index. So this is to create pseudo linear index. Now what we do? Now what I am doing is exactly the thing that is given in the pseudocode. Okay, we run a loop over j, and there is a switch command. Okay, switch command is doing something like this. I will make a switch code for switch command only. Okay, so let me show you what is clear the switch command. I will clear ways. So we CLC. So let's give an input j is equal to 1, and if you write switch j, it will switch according to the value of j. I can give whatever cases I want. If j is equal to 1, I want to display say 5. Just print 5. Okay, just write 5. If j is 2, print 7. Otherwise, print 9. So very simple, handy code. Okay. So just let me just save it. So use of switch. So j is 1. You get 5. Okay. So let's again. Okay, let me change j is equal to 10. So that is otherwise case. So I should get 9. Get 9. Okay. So it selectively executes one case. Okay. So that's what we are doing here. I am running a loop over j, that is the level, white level. Okay. And then I am switching. If j is equal to 1, that means the first layer, then I am having some boundary information. This we have incorporated in the pseudocode also here, see here. When j is equal to 1, the stencil is different. When j is equal to capital J, the stencil is, the scheme is different. And when j is between 2 and capital J minus 1, the scheme is different. Okay. So we are trying to implement this one. So I will do one thing. I will show my code and give you some time to type this one. So are you guys with me or everybody is asleep? It's afternoon. It's a good chance for that. No thanks. So basically we are giving the row number m that is calculated as I plus j minus 1 capital J and ELL of 2 1. So this is the column number that corresponding to indices 2 and 1, 1 and 1, 1 and 2. Okay?
Go be too fast.
Too fast. Okay. So which part I started go fast? Where should I start explaining again?
Ask them whether they understood switch command.
Did you understand switch command? Response is the switch command okay?
Yeah. Yes.
Okay. Inline function, amorphous function, was that okay?
Switch is good.
Yes, okay.
So then now what we have to start is the for loop. How do you input? How do you construct the coefficient matrix A? Right? Okay.
Inline is also cool.
I think you are just talking fast. That's it.
Oh, that happens, when you take back-to-back classes at some time, you will lose the sense of reality. I'm very sorry, I will go a little bit slow. Yeah, now what we have to do is we have to construct the matrix A, which is the coefficient matrix which we have to do the inversion. Okay, so what we have to do, we have to just give the entries of A. Okay, the entries of A depends on what is the J value and what is I value. Now there are three cases for the J level, that is the Y coordinate. My J value can be 1, it can be capital J, which are the boundary levels. Okay, the highest level and the top level. J is equal to 1 and J is equal to capital J. Okay, these two, since they are involving boundary data, we have to incorporate that also. Then there are values from J plus 1, so there are values from J equal to 2 to J equal to capital J minus 1. So there are three cases for the vertical value. The lower boundary data, the stencil in between these two, and the upper boundary data. Okay, so these three cases has to be treated differently. So Rekha explained that in the morning. Let us take J is equal to 1 again. Let's look at pseudocode again. What is being done there? Yeah, look at here. When J is equal to 1, the scheme reads as ui plus 1 1 plus ui minus 1 1 minus 4 ui n minus 1 plus ui2 plus ui0 equal to minus h square. But this is a boundary data ui0, which is 0. Okay, so the scheme has only 4 terms. First to 4 terms. Okay, so this is the coefficient. So what we are doing is we are multiplying a with u1 up to uj square. The coefficient of A, the entry in A that corresponding to the coefficient I plus 1 1 is 1, because ui plus 1 is multiplied by 1, whereas ui1 is multiplied by minus 4. Now we have to find in A where are these numbers going. Okay, now j is equal to 1, so let's take I equal to 1 and j equal to 1, I equal to 1. this I equal to 1, the row number, that is the 1 1 equation corresponding to x1 y1, which corresponds to pseudo index m equal to 1. So this is my first equation. My first variable is x1 y1. My first equation is m equal to 1. So I take j equal to 1 or I equal to 1. That is x1 y1. And my equation will be I equal to 1. When we put I equal to 1, what do we get? We will get u21 plus u01. u01 is also 0 because of the boundary data. So you get u21 minus 4u11 plus u12 equal to minus h square f of x1 y1. Is that clear?
Yes.
Okay. Now, when you have u11, which column that value belongs? Okay. So 11 corresponds to which pseudo index, that we have to think. That we can calculate. I know x value, y value, I value is 1, j value is 1. Okay. So what will be your m value? M value will be ELL of 1 1. So that belongs to, this coefficient 1 belongs to row number 1, column number ELL of 1 1. Then there is minus 4. That is minus 4 belongs, minus 4 is minus 4 u11. That belongs to row number 1, column number ELL of 1 1. Likewise, you have to assign the coefficient values to the row in to which row and which column in A. That's what basically we are doing. And then if you have all the sub cases for j is equal to 1, j is equal to capital J, and j is equal to 2 up to j minus 1. When is the next break?
You have
3
20
minutes.
20 minutes. You have 20 minutes.
Yeah, 25 minutes. 20 minutes.
So let me go back to the MATLAB.
1 4.
Maybe. Switch j, we are taking case is equal to 1. So when we call case equal to 1, this will consider the case when j equal to 1. Okay. Now look at here. This is what I told. The assignments we are doing. So j is, we have a j value which is 1 in this case, and we have an I value which is 1 in this case. Okay. So inside a j loop there is a I loop also, because we have to run over each I value. So I fix a vertical level, okay, and then I have to assign all x values. Then I go to the next vertical level, I assign at all x values, and I go up to the highest level. So that's what we are doing. So there is a j loop which stacks over the vertical levels, and there is an I loop which stacks over the horizontal levels. Okay. Now I take I equal to 1. Okay. Then as I said, on a mth row, ELL to 1 column, that goes to 1. Remember, this was the first stencil we required. That is x11 scheme, equation for x11. Then a m ELL 11, that is minus 4. Then a m ELL 12 is 1. So these are the coefficients. Basically, when the matrix operates over U, it becomes u21 minus 4u11 plus u12 equal to minus h square. Similarly, the other one, when I equal to j, what happens? You have a similar stencil, similar scheme. So you put the corresponding column row number and corresponding column number and assign the coefficient values there. Okay. Then there are intermediate cases. If I not equal to 1 and I capital not equal to j, there is a value from 2 to j minus 1. There what calculation we have to do? We have to create the row number and what are the column numbers. Okay. Then I increase I equal to I plus 1, complete the horizontal loop, and then go again to the top of the vertical loop. Do this for the next j. Okay. That's what we are doing here. Does it make sense to you? Now what I can do is that it's a little bit confusing. I know Poisson scheme even for teachers is a little bit confusing. What you have to do is that read the pseudocode we have sent to you in the notes and try to match it with the code, the construction of it. It will take half an hour to 1 hour, but if you do that, it's a very good exercise. You will understand how the matrix is being considered, and it involves a lot of thinking. So it will give you a good leverage on writing MATLAB codes. So do take that exercise seriously if you get some time. I know all of you are busy, so but If you get some time, do that exercise. It's a wonderful tool to do. Okay, so then we construct what is B, the load vector. Okay, maybe I will take some questions here. I think it's too much I am talking.
Yes, we can take the question.
Yeah.
For 15 minutes.
Functions, loops, memory, speed, can ask anything. Or from the previous parts also. Or implementation of this part also.
Yes, please you can unmute yourself if you have question and you can ask.
Or do one thing. Uh, you can just type this one. How can we send them this file? No. I think Sunita, can she send?
Yes, you can send. We can also send maybe. Yes, Sunita is
You can
sending
put in
it.
this Telegram group, right? Code.
Yeah.
Okay.
Telegram will
Yeah, I will do one thing. I'll put the code in the Telegram group, and you can download it. Just run it.
We are assuming that all you are there in the Telegram group also. We have to share one file there.
Sir, can you again tell what ELL is?
So can you again tell what all is? What do you mean, Karan? You wanted to repeat it again?
Yeah.
Repeating?
ELL, we define ELL function.
Oh, ELL,
Yeah.
okay. What ELL is? I thought you did all.
No.
So I am going to give you four files. Download it and put them in one folder. And you can run sort person. Okay. What was the question?
ELL is.
Can you again tell what ELL?
What is ELL?
ELL. ELL is a function. So see, maybe I will go. I think if I can write it better. I will write
Stop
it.
sharing.
Yeah, I will stop sharing here.
Stop.
Yeah. So the ELL, let me explain.
Now you can start. No.
Maybe I will take a small example. We will take a small example. Let's take, and you will understand what's going on. Let's take a small one. So how many unknowns are here? So this one, this one, this one, this one, this one, this one, this one. Okay, so this is U11, this is U21, this is U31, second level, third level. Okay, now what's the pseudo indexing we are using? The pseudo indexing is U11, U13. I'm calling by a different name, U1, U2, u3. Okay, and u next level u21, u22, this is u4, 5, u6. Yeah, third level. u7, u9. Basically, we are traversing in this direction. That clear? Okay. Now let me write. Now let me write the scheme for all of this one. Okay, let me do a little bit bigger adventure. Maybe I have 20 minutes, so we can do a little bit. What we want to construct is a matrix for so what will be the first equation for u11? When I write the stencil, I will get u so this is equation 1, which is u11 minus 4u11 minus 4u11 plus u12 plus u10 u01 plus u21 equal to minus h square f of x1 y1.
Do it.
Okay, now by boundary condition, this guy and this guy are 0. 0, 0.
Waiting.
Okay, so what will be the modified equation? The modified equation will be u21 minus 4u11 plus u12 is equal to minus h square of x1 y1. Okay, that is my first equation. Now let me write my second equation. So little bit maths. Should be u of 22 minus 4 plus u23 plus u21, and here it will be u12 plus u32 will be minus h square. Oh my god, it should be u12. I'm sorry. Very sorry. Should be minus 4 u first level, second entry. So plus u22 plus u20 u11 plus u31 equal to minus h square f4 x2 y1. Now by boundary data, u of 20 will be 0. So this will be u11 plus u31 minus 4u21 plus u22 equal to minus h square f4 x2 y1. Likewise, you write equations for each of these entries. For this entry, this entry, this entry, these guys, two guys we did like this, all the 9 entries. Okay, so you see we can write now u11 something like u12, u13, u second level 1, second level 2, second level 3, third level 1, third level 2, third level 3. Now the problem is, in MATLAB we cannot say it is the two-dimensional array number. Okay, so we have to connect 1 1 2 to some a linear number, a one-dimensional number. That's why we are using ELL. So when we call ELL of 1 2 1 1, it will create 1. Okay, so instead of U11 in MATLAB we will write U1. U21 in MATLAB we will write U2. U31 we will write U3. U12 4 5 6 7 U8 U9. So the function of ELL of ij is creating the one-dimensional index for the two-dimensional array numbers, indices. Okay, now what are the coefficients here? So let's write this coefficient, which is the matrix construction we are using. In the first equation, what is the coefficient of U11? It is -4. See, it is -4. So here I will put -4. What is the coefficient of U21? It's 1. What's the coefficient of U31? 0. U12, it's 1. Okay, all other entries are 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's my first row. In the second row, what I am doing? Look at the second row. U11, the coefficient is 1. U21, it is -4. U31, it is 1. See, U31, it is 1. U21, 4, -4. And U11, 1. And U2, then U12, 0. U22, 1. 0, 0, 0, 0. Okay. Now I will tell you what I am going to write the entire matrix. I don't want any help because this is very easy. The next one will be 0, 1, -4. 0, 0, 1. 0, 0, 0. The next one will be zeros. Will be there's a structure for this, you know. You want 0, 0, 0, 1, 0, 0, 0, 1. Then -4, 1, 0, 1, -4, 0, 1, 0, 1, -4, 0, 0, 0, 0, sorry, like that. 0, 0, 0, 1, 0, 0, 0, 1. Okay, then finally it will be 0, 0, 0, 0, 0, 0, 0, 0. Then 1, 0, 0, 0, 1, 0, 0, 0, 1. Root -4, 1, 0, 1, -4, 1, 0, 1, -4. Okay, so these numbers are coming from, so this is coming from, I will write what is this is coming from. This is coming from x1, y1. This is coming from x1, y2. This is coming from x1, y3. This is coming from x2, y1, x2, y2, x2, y3, x3, y1, x3, y2, x3, y3. Okay, so this is the matrix that we are trying to implement, which is equal to what? We have minus h square f of x1, y1 up to f of xj, yj. Is that clear? So that's a lot of mathematical place. Is that clear? Some idea did you get? I mean, can you take it from here? Yeah, now I will go to MATLAB again. Okay, so that the coefficient, so this is the linear indexing. You know, I have to connect the two-dimensional array to one-dimensional. That's the job of ELL. Any other questions? Did you get the code, all of you? Okay, now let's, so this is again the implementation of B of M, the load vector, again the same idea, S square, the function, the source term at xy, x of I plus 1, yj plus 1, yes, as we did. And we are inverting, so AU equal to B, so our equation is AU equal to B. So MATLAB has, you know, a very nice way of finding inverse. You just take A by B, A backward slash B. So this will just do A inverse B. It's a very powerful command. Just write A inverse B, it will compute it. Okay. So now let me just run it and show you the displacement. Oh, I'm sorry, I haven't shared my screen, right? You should have informed me. I'm so very sorry. So what I was telling is that you have the source term assignment, and we got U, we got B. How do you find U? Just take A inverse B. So our equation is A equal to B. How do you find U equal to A by B? So if you type A by B, MATLAB will do this operation. This is equal to inverse of A times B. Okay. So let's just run this one. Produce a figure. Yeah. So that's the displacement. So you can see we are giving an upward force. So the highest displacement is at the top, and boundary there is no displacement. Actually, I haven't plotted the boundary data. It should be 0 here. Okay. Now let's see. So this for to show this in MATLAB, we use something called mesh plot. Okay. So basically, we have to give what is x data, that is here, y data, and you have to create. I did it manually. There is something called mesh grid generation also, which you can explore. Okay, I'm not very much into this because this is typical MATLAB stuff. I want to show how you can plot this in ParaView, okay, which is also useful in when we do heat equation. Again, we do the same thing. We create a file name Poisson data.csv. We will give write permission. Oh, okay, sorry, don't look at that. Okay, this is something else. I need to introduce. Yeah, have I said about what is percentage command? Percentage command means the command, so you can write anything you want. Okay, so this is about how do you comment. So percentage stands for comment. This is the, yeah. Now I want to plot this in ParaView, but the problem with ParaView is it's usually inbuilt for triangular data or unstructured data. Okay, but we are having a two-dimensional array. How can we make a triangulation out of triangulation? Triangulation means we need to discretize your domain into triangles. Morning Rekha draw a figure, that square domain into triangles, something like that. So how do you do this? So what you do is that first we will make a coordinate vector. So you should not give too much attention to this part. It's a little bit fussy. We will create a vector called code j square 2. So this is to store coordinate data. This may be some confusion might come here. If you have, ask questions. Okay. Yeah. Now what we do is that mth coordinate value we will store as our xy. Okay. So basically, it's the same linear indexing we are using. The code will have the structure x1, y1, x2, y1, xi, y1, like that. Okay, so it's a way to create the coordinate. Now if you give this code to, there's a command in MATLAB called delone, it will create a triangulation for it. So don't worry about what is LM and all. It's a connectivity matrix. Okay, just imagine that this will give you the addresses of triangles. Okay, so take that as a black box, and I will just plot it for you. That is okay. So this is what I said. You will get a triangulation of the domain. You see, the entire square is divided into triangles. Okay, so instead of grids, now we are having triangles. The good thing with triangulation is we can easily write this data as a BTK file. VTK files, okay, this is our second part we have to understand. VTK file stands for Visualization Toolkit. Okay, that's a proprietary extension by Kiteware, where we can store, you know, polygonal data. Okay, I will just show you a VTK file and tell you what are its components. So VTK file construction itself is another universe. So basically, there are functions that is being written that if you just give the triangle connectivity matrix elements and coordinates, it will create the VTK data structure for you. You don't have to do anything manually. Okay. So basically, we are saying that we are dealing with an unstructured grid example. We are going to write everything in ASCII code. Okay, data structure for unstructured. So these are the default header file for the VTK file. Okay, so we'll just create fprintf commands to write all these things. Okay, then we are giving 400 plot points. So this is x value, y value, z value. By default, z value is 0 because we are having only two-dimensional plots. Okay, so we give the x value, y value. This is my chord matrix, that is the grid that x1, y1, x1, y2 up to x1, y. That's that one. So we have points, and these are the addresses of the elements. Okay, so basically this is it says that we have 722 triangles, 288 data points, and it's giving which coordinates joins. So 300, point number 300, 370, 371, that forms a triangle. 329, 349, 371, that forms a triangle, etc. that way. So this data format is important in writing VTK files. You know, ParaView performs according to that type. Then it has cell types, you know, how many neighbors it has, all these things. Okay, you don't have to worry too much about this thing. You have just take this as a black box. What it does is that we have a function called write VTK. I have sent this to you. What write VTK do is that if you give element value, coordinate value, and element value means the triangle data, this one. So give triangle addresses and your function value u. What is u? U is my solution. If you give that, it will generate a VTK file for you. You don't have to do anything. Okay. So it has created a test VTK file. Then you go to ParaView. Same procedure. Open ParaView. Code PJC, codes PJC, pause on. Yeah, good. Now you have the test 2D, and just as we did in the case of transport, just drag it. Click your file. Just drag it. Yes. What happened? Oh, sorry.
What did it?
I think I made some mistake. Yeah. Shouldn't be like that. This one. Let me check again. But test 2D will just fight. Not fight. Yeah. Seeing some error. Oh, okay, fine. I'm very sorry. It cannot take sparse input, so I have to convert you into full data. So I will write full of you. Yeah. It have to give all numbers. Okay. I forget about this. Yeah. Cool. Now let's go here. I will open another render window. You know, the VTK, once you got a hint of this, you can experiment on it yourself. But the issue is, what I found is somebody has to introduce you. So you see there's a problem here. Somehow this color scheme is not proper. Let's try to fix that. Yeah, my ParaView is again stuck. Somehow there is an issue with ParaView today. It's getting again and again stuck. It's unfortunate. Maybe we can stop here and I will fix this problem. I can show you how the plot look like.
Break.
We can take that.
Yeah.
4-5 पे मिलते हैं 4-5 पे मिलते हैं
10 minutes break.
10 minutes maybe. Okay, I'm putting message. We'll meet at 4-5 again. Huh?
Yeah. Okay, we'll start the session at 4-5.
Yes.
The final process image will look like this.
Achha.
When we make it ParaView.
Oh.
So let me try how this is doing. Okay, and you can also experiment. We'll meet after that break.
Okay, we'll come back again at 4-5.
Or 5.
Just in 10 minutes maybe.